All right, so I want to take a few moments to talk about why the variance of x bar, or the sample mean, equals sigma squared divided by n. All right, so why is that? All right, first thing, I just want to talk about some notation. So the variance of x, so a single value of x is equal to sigma squared. All right, so I can write that as xi. All right, so for all I equals 1 to n. All right, the variance of xi is sigma squared. Also, what is x bar? X bar is the sample mean, which is the sum of xi from I equals 1 to n, okay, divided by n. Okay, so this is what x bar is. So basically what I want to find is the variance of x bar, and then I will show that it is what you see here. Okay, so let's find what is the variance of x bar. This is going to be the same thing as the variance of 1 over n, the sum of I equals 1 to n of xi. Okay, so I just basically pull that denominator out front, so it's 1 over n times the sum. All right, so now you need to know a property about variance. So if I have the variance of some constant, and then I have a random variable, so I don't want to use x, because I'm already using x. Suppose my random variable is just y. Okay, so the variance of some constant times the random variable, this equals a squared, so that constant can come out, and when it comes out, it gets squared, times the variance of y. Okay, so a is a constant, and y is a random variable. All right, so we're going to use that. Okay, so x is a random variable, right? It has variability here. All right, and n is our sample size. So 1 over n is a constant. All right, so I'm going to go ahead and pull that out, and I have 1 over n squared times the variance of this sum. All right. So another property of variance, say I have the variance of two random variables. I'll just go x plus y. So x is another random variable. All right. This is going to equal the variance of x plus the variance of y. So I can break up that sum. So now when I see this sum here, I can basically pull that summation out. All right, so let's do that. 1 over n squared times the sum from I equals 1 to n of the variance of xi. All right, now the variance of xi, I've already discussed that this equals sigma squared, right? That's up here. I've made that assumption that all xi's have the same variance and they're all sigma squared. All right. So let's go ahead and plug that in. I have 1 over n squared times the sum from I equals 1 to n of sigma squared. Now, sigma squared now does not have an I, right? All xi's have the same variance, so there's no need for that subscript I. All right, so when I sum up sigma squared n times, I'm going to get n of them. So this equals 1 over n squared times n sigma squared, right? When I sum sigma squared n times, I'm going to get n of them. So I'll have n times sigma squared. Right, so like, for example, suppose if, let's kind of talk about this a little further. Suppose n were like 3, and I was summing up and say sigma was 4, right? So when I sum 4 3 times, I'll get 4 plus 4 plus 4, which is the same thing as 3 times 4, right? So I've summed up n times the same thing. So that's how I'm getting n times whatever that sigma squared is. Okay, so that's what you see here. All right, so now we have a little bit of a cancellation, right? Because I can bring this 1 squared is just 1, n squared, right? So I'm bringing that square term in, n times sigma squared. So this guy cancels with that guy, and I'm left with sigma squared in the numerator and just 1n in the denominator. Okay, so this is the variance of X bar. All right.